Glad to have you back. This is the second part of the lecture that I started explaining math and dimensional analysis and how that relates to energy and power. Again, I'm overjoyed to have you return. You go out and buy a faucet aerator or a low flow shower head or LED bulbs, and the big thing now is, oh, save you money, and they will save you money, but you can't claim that that product is going to save you money until the initial investment has been paid off, which I want to go over that with you in this part of the lecture. The payback period of a product in years would be the initial investment divided by the savings per year. Like, for example, I brought up faucet aerators, those little things that you can screw onto your faucet that infuses air and displaces water, which saves you water. One of those could cost $4, and it could save you $1.30 per year. Not a lot, but you can't claim that faucet aerator saves you money until that $4 has been paid off. So to figure that payback period out, you would put $4 and divided by $1.30. That's the savings per year, which this gives you 3.07 years is the payback period. And exactly then, you can claim that that faucet aerator saves you money. Once that faucet aerator is paid off, $1.30, money in the bank. Here's another example, and at any time, I want you to pause and try it on your own, and then come back to the video to see how I'm doing it. Now, one year for my lifestyle change, I couldn't figure out what to do, so Mr. Cavo allowed me in his home, and I conducted an energy audit on his home. I noticed that he had 5 lamps, and each lamp had a 60-watt light bulb, and he left them on every night for 8 hours. He claims that he forgot, but really we all know what was happening. He's just afraid of the dark, which is totally cool. I'm afraid of the dark too, whatever. Nonetheless, I offered him a solution. Maybe we can buy one of these timers that automatically shuts the light off so we can cut the usage in half. Each timer costs $4, and the question is, how soon will Mr. Cavo pay the initial cost of the timer's off? In years, and then you can put your answer in months if you want. So the first thing we need to do is figure out how much he's spending on powering those light bulbs for the 8-hour duration, the old way. So let's just do the old way. And he has 5 lamps. And remember, start with the units first, because that will tell you where the numbers go. We know that lamps have to go down here to cancel that lamps out, and each lamp runs off of 60 watts. And up here I gave you the conversion. 1,000 watts is equal to a kilowatt, and 8 cents is equal to 1 kilowatt hour. Well, we know that watts has to go down here to cancel that watt out, and there are 1,000 watts in a kilowatt. Okay? Now we need to keep going. We need to find out how much this is costing Mr. Cavo. We know that all 5 of these lamps are on for 8 hours, and that's in a day, 8 hours per day for the entire year, which is 365 days. And my days cancel in 1 year. And last thing that we need to do, up here tells you that there's one for every kilowatt hour is going to cost Mr. Cavo 8 cents roughly. So I'm going to put 0.08 and 1 kilowatt hour below. Now this kilowatt hour cancels out hour times kilowatt, because remember in my previous lecture I told you that a kilowatt times an hour is a kilowatt hour. So this kilowatt hour cancels out that hour and that kilowatt. So now what we're left with, the only 2 units left standing, is money per year. And when you do the math, he's spending $70.08 per year doing it the old way. Now, the new way, let me change colors so it's easier. Here's the new way. We can assume all this stuff is right. He still has 5 lamps, not right, but the same. He still has, each lamp is 60 watts. The 1,000 watts in a kilowatt, but the only thing in this dimensional analysis strand that it's different really is this section, because we're using this timer to shut the lights off automatically to shave it in half, which is 4 hours a day instead of 8 hours a day. Everything else is the same. You can just drop everything down. So when you do it the old way compared to the new way, so the new way is now $35.04 per year. Just like in red when I just showed it to you, that all the units cancel out except for dollars per year, which luckily in this problem, it's perfect. He cut the usage in half, so technically you could just take 70.08 divided by 2. But what if it wasn't by half? I just wanted to show you the math. So we're not done yet, because it said, how soon will Mr. Cavo pay off the initial investment? Well, now we need to figure out how much he is saving by doing it the old way compared to the new way. I'm sorry, by doing it the new way. So you take the old way and you subtract the new way, and again, it works out pretty nicely because you're just cutting the usage in half. And Mr. Cavo is saving $35.04 per year. You can't claim that he's saving $35.04 per year until the cost of these devices are paid off. So let's calculate the payback period now. Now let's put that in green. Payback period. He has to buy 5 of these things at $4 each, which his initial investment is 20 buckaroos. So that is, the initial investment is $20, and he is saving $35.04 per year. So when you take those two and you compare, you're going to get 0.57 years. That is the payback period. So about a half a year. Now, if you want to convert this to months to make it, when you have a very small fraction of a year, like 0.1 year, it might be a little bit more easier to understand if you put your answer in months, so, or even days. So to do that, you set up a dimensional analysis. You know that years go on the bottom, and the years cancel out, which then we know that there are 12 months in a year. So when you do the math, you are going to get 0.57 times 12, and that is going to be equal to 6.84 months, which again is about a half a year, a little bit more. So now you can tell Mr. Cavo and have a a better argument using math to back up your claims that the payback period is not like 35 years and never going to get your money back. He's going to get his money back in 6.84 months, and then every year after that, for the life of the product, he is going to bank $35.04 per year, every year, until he stops using that or until the product dies. Go, Mr. Cavo. Woo!